Alright, so this next video we'll pick up on question number 8 and we'll go as far as we can. So we're going to start with solving for the x. Remember, we just cross multiply and divide. So 8 times 2 is 16 divided by 3. It's either 16 divided by 3 or 5 and a third or 5.3 repeating, any of those things. And then number 9. Again, you're going to set up that this equals this. So it's like cross multiplying and dividing, but proportionally multiplying across has to equal multiplying across. So 4 times x minus 2 equals 7 times x plus 1. And then you can either put this in the calculator as y1 and y2 and find where your y values are the same. Just remember that it could possibly be a decimal. If you're working with a multiple choice test, though, you could be able to just look for those specific decimals. Or you can just solve it by hand. 4x minus 8 equals 7x plus 7. All I did was distribute there. And then I move all my x's to one side and move all my numbers to the other side. Then divide to solve for x. So x would equal negative 5. Again, if you don't like doing this, you could do the calculator y1, y2. Moving on to number 10. Find the slope of the line passing through points. I just like to set up a table. You could also use the slope formula, finding the change in x and change in y. So this is plus 7. And this is plus 4. And then this is how you set it up. So my change in my y values was 7, and my change in my x values was 4. So that would just be 7 over 4. Just as a little bit of some extra information, parallel lines would have the same slope of 7 over 4. Perpendicular lines would have the opposite reciprocal slope of negative 4 over 7. Just a little bit of extra stuff for you. Number 11, again finding the slope. So I would set up a chart, then find the change in my y's, which is negative 6. Change in my x's, which is plus 3. Change in y over change in x, negative 6 over 3, which equals negative 2. So my slope is negative 2. Parallel lines would equal negative 2. Perpendicular lines would equal positive 1/2. Oops. So this is important to know if you're looking at parallel and perpendicular lines either on a graph or having to write the equation of parallel and perpendicular lines, or choosing what would be the right equation. Number 12, find the length of a segment. Length, that's the distance. So you're going to need to use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. You take the square root of all of that. Remember, it doesn't matter which point you use for 1 and 2 as long as you use the same one. And then a lot of you are just really good about putting the whole thing in your calculator and pushing enter. So I'm going to use this as 0.2 and this is 0.1. So it'll be 6 minus 2 squared plus negative 7 minus negative 3 squared. This is the same as plus 3 minus a negative, and you end up with the square root of 32, which you can leave it like that for 5.657. Just as a few notes, if you do it with more steps, you would end up with the square root of, this is 4 squared, which is 16, plus negative 7 minus negative 3 is like negative 7 plus 3, which is negative 4 squared, which is 16. So if you did a few more steps, you should have gotten that, which then gets you to the square root of 32. Whew. Number 13. Oh, also this formula will be available to you on a formula chart as well as on the poster in the classroom. The midpoint. Again, formula chart or classroom poster. Add the x's and divide by 2, add the y's and divide by 2, and that's your point. So we have 8 plus 12 divided by 2 and 6 plus negative 4 divided by 2. 8 plus 12 is 20 divided by 2 is 10. 6 plus negative 4 is 2 divided by 2 is 1. So that would be the midpoint. Number 14. This is where I told you that point C is negative 1. I don't know what happened to it. I just got cut off. So the coordinates of point E, what's important is to know that the diagonals of a square bisect each other. So that means that this is congruent to this, and this is congruent to this. So essentially, point E is the midpoint of A and C. So we're looking for the midpoint. So we have this same formula up here. So I can add my x's and divide by 2. I can add my y's and divide by 2. And I end up with 0 plus 4 is 4 divided by 2 is 2. And then 7 plus negative 1 is 6 divided by 2 is 3. Number 15. This part really goes right here. I don't know how it got pushed down so far. But I have this plus this equals this. This is segment addition. So I'm going to set up 5x plus 1 plus 9x minus 6 equals 12x plus 12. This is another situation that you could do all of this in y1 and all of this in y2. Or you can solve it by hand by combining like terms. And then rearranging, adding all my x's over here, which is 2x, putting all my y's over here, which is 17, and x is 8.5. And then to find out what everything is, you would just replace your x into all these points, or into all of these expressions. So this is 5 times 8.5 plus 1. This is 9 times 8.5 minus 6. And this is 12 times 8.5 plus 12. So you would just replace your x in each of these with the x value you just got. And you end up with 43.5, 70.5, and 114. And remember, these two should add up to give you that. So that's another thing that you can check to be sure that you're right. So after you get your x and you plug all these in, if you add those up and you don't get that, then you probably did something wrong. And that's an excellent thing to always be checking. 16 is the same type of problem as 15. So we have 2x plus 15 plus x equals 27. So all together I have 4x plus 15 equals 27. I can subtract 15 from both sides and get 4x equals 12, so x equals 3. And then again, plugging this x into all of these. 2 times 3 is 6. 3 plus 15 is 18. X is just 3. And if I add all these together, I should get 27, which I do, so I know that I did it right. 17. This means that these two parts are congruent. So I can set these two segments equal to each other. Again, another situation that you could use y1 and y2, or solving it by hand, would look like this. And then plugging all of this back in. So 4 times 17 plus 4, 6 times 17 minus 30. Will give you 72 and 72. These were supposed to be congruent, and they are, so we did it right. And then adding those together to get AC would give you 144. I'm trying to decide if I want to do this on this video. Okay. So this is name at least 2 pairs of the indicated angles. So remembering what all of these things mean. Alternate is opposite side of transversal. Same side would be the same side as transversal. And then interior means between the parallel lines. Exterior would mean outside the parallel lines. Corresponding is the same location. Linear pairs make a straight line. Vertical angles are across the X from each other. So, alternate interior angles. We have to be inside the parallel lines, so that's 3, 4, 5, and 6. And then alternate sides, so 3 and 6 is one set, and 4 and 5 is another set. Same side interior angles, so I'm still inside these 4 here. Same side would be 3 and 5, or 4 and 6. Alternate exterior, so now I'm moving outside of the parallel lines, looking at 1, 2, 7, and 8. Alternate is opposite sides, so 1 and 8, and 2 and 7. Vertical angles are just across from each other, so like 1 and 4, 2 and 3, and then also 5 and 8, and 6 and 7 are another set. Corresponding angles in the same location would be like 1 and 5, 4 and 8. So 1 and 5 are both the top part of the group, and they're on the left. So that's what it means by corresponding. Then linear pairs make a straight line, like 1 and 2, or like 5 and 7. So one other thing I want to tell you about these before I stop this video. Alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. Same side interior angles equal 180 degrees. Vertical angles are congruent, and linear pair equal 180 degrees. Okay, so these are supplementary, and then these others, they are congruent to each other. I'll go ahead and do 19 because it's quick and we kind of already talked about it. If I have an equation, parallel lines have the same slope. So the slope would be 5. So y equals 5x, and then anything after that, plus any number, minus any number. Perpendicular, I look for my slope and do opposite reciprocal. So I change the sign, so now it has to be negative, and I flip the fraction, and then it could be plus or minus anything after that. This is only true when in slope-intercept form. So if it's in standard form or it's in a different form, you need to change it to slope-intercept form in order to compare your slopes. So only when in slope-intercept form can you use these tricks. So I'm going to pause it there, and then I'll keep going on the next video for the next step.